So we thought we'd start out with just a high-level video of really what is GIS. And we thought that this video that we'll play next really captures very quickly what GIS is and why it really matters in today's environment and in society. So let's go ahead and play this. Go to
GIS stands for Geographic Information System. Using computer hardware and software and a ton of raw data, we can explore the fundamental principle of geography. Application is important in people's lives. Using GIS, we can view, understand, question, visualize, and interpret data in visual ways that reveal relationships and patterns, which allows us to make better decisions. For example, a meteorologist might study the paths of hurricanes to predict where and when they might occur in the future. A city planner can choose the best location for a new park or hospital, ensuring that they are built in the place where they're needed the most. GIS is essential to understanding what has happened, what is happening, and what will happen in geographic space. Geographic understanding brings wisdom, and with wisdom, we can make better decisions to create a brighter future.
Okay, so as we've seen in the video, the GIS integrates many components like the hardware, the software, the data, and of course the people which working with the GIS. And our GIS is evolving and it's becoming more and more part of an interconnected platform, which basically means that the servers are connected, the desktops are connected, and the apps can be fed with shared content, which doesn't necessarily mean that you have to share all of your content, but it's definitely an emerging trend to use shared content in your applications. In this sense, we like to talk about a web GIS, where web doesn't simply mean the internet, but more web services as a new pattern, so services in the web. And of course, the GIS is co-evolving with everything else around it. For example, faster computing, modern devices, new web standards, new network technologies, and of course the cloud as well. And therefore, it's bringing together data, technology, and people to create a powerful framework for solving complex problems. And our GIS integrates all types of information. And you can share and organize your work using web maps and services. This basically means that your maps become services for other people to use. Your analytics can become services for other people. And you can use imagery and data as services in your applications. It also integrates all types of data. For example, big data, your enterprise data, social media, or real-time, which is what we would like to focus on in today's presentation.
So really the data that's fueled GIS in the past was typically created to represent the state of something at a specific moment in time. So whether that was, as the video stated, what has happened in the past, what is happening now, and what will happen at some point in the future. So while that's proved really valuable for all of the countless applications and analyses we've all performed using GIS, what we're coming to find out is that that current snapshot, or what is happening now, is essentially outdated at the moment it's created. So, especially in today's fast-paced and constantly changing world, that content really is, especially with mobile devices and smartphones and other connected devices, it is essentially outdated after the second after it's created. So what is real-time GIS data then? So we can characterize it really as a continuous stream of events flowing from sensors or a feed, where each event is going to represent the latest state of that sensor or that feed. So if we look at a couple different user communities here and how they might utilize real-time GIS data, the first being emergency responders. So you might have vehicles with in-vehicle GPS devices that are transmitting their location every second or so. Officers may have radios that transmit their location every second as well, or whenever they communicate with folks. So command center might want to see this information and visually represent that information on a map to see where all their assets are in the field. So utilities are another great example of using real-time GIS data to view a live status of their network. So they might have sensors out in the field that are constantly transmitting real-time information. So those sensors aren't physically moving, but the sensor itself is transmitting loads of information constantly. So RFID is also being used in a wide variety of environments to keep track of items of interest. So warehouses are using it to track and monitor inventory levels. Hospitals are using it for monitoring to make sure equipment has gone through the proper cleaning procedures before it enters another patient's room. There's also a wealth of volunteer geographic information available. Two examples here are really USGS and NOAA provide real-time feeds of storm wind, temperature, earthquake, and wildfire feeds that you can connect to and add into a GIS for additional context and situational awareness. So modeling each of these features in GIS is pretty easy. The challenge comes in when you try to incorporate all these different feeds into the GIS. Right? The reason, obviously, is because there's tons of different manufacturers of devices and sensors, each is communicating with different data formats and different protocols. So having, so really that is, I guess, the first challenge of real-time GIS. And having that ability to bring in multiple data sources from all these disparate devices and sensors, other assets that are out in the field that are transmitting that information in real time. So while it's easy to connect a sensor to a feature and then display it in near real time, the next thing you might want to do is perform some continuous processing or analysis on that data after you receive the information in the event. So in this scenario here, we're monitoring fishing vessels and detecting when they're inside a no fishing zone. So you can see in the illustration above, we actually have a filter here that's going to be constantly monitoring that feed of information and detecting when a vessel enters the no fishing zone. You can see we receive alerts and the different symbols for the assets that are inside the no fishing zone. So the second challenge of real-time GIS is really that ability to perform this real-time processing and analysis on the data as you're actually receiving it in real time. So here we have another example of continuous analysis on a stream of data. So in this scenario here, we want to tell a parent when a child leaves school property. So you can see that we're updating this child feature here with the child's current location. But at the same time, we have another processor here that's detecting when the child actually does leave the school boundary. And when, in fact, that child does leave the school boundary, the parent could be notified via, in this case, SMS, text message, or email of that fact. So sending these kinds of alerts and updates to those who need it and where they need it is really the third challenge of real-time GIS. There's obviously a lot of communities of interest or stakeholders for information you might be trying to transmit out to your stakeholders, I guess. So having the ability to route these events of interest to these various communities of stakeholders is really important. And then equally important is that ability to provide those updates and alerts where they need it. So whether that's a smartphone, business's internal application, or maybe it's an operational display that's going to be deployed at an emergency operations center or some other application that is used at an organization. So what we're going to be focusing on today a little bit is the Geodon extension. So this is a new extension to Esri's platform that allows you to really accomplish those three things and those three challenges that I just highlighted. So the first being the ability to integrate all these different types of devices and data sources into the ArcGIS platform. So you can see social media feeds from Instagram, Twitter, GPS devices that might be inside of different modes of transportation, like vessels, aircraft, and trucks. We can also connect to any number of sensors out in the environment. So sensors that are on a utilities pipeline, again, capturing information about the pipeline status. Business systems, and even like RFID chips or panic buttons that your field crew that are maybe working in a volatile work environment can press, and operations can be alerted upon that depressing of that panic button. So now once you bring that data into the ArcGIS platform, into GeoEvent, you have the ability to perform that processing and analysis. So you can do some filtering on the data. So if you're only interested in 5 of the 100 fields on the incoming data, you can filter out just those 5. You can also do things like we kind of highlighted in the previous scenarios. Incident detection, so you can detect when a vessel is inside a certain boundary or a geofence or some other spatial boundary. Now the third real high-level capability of the GeoEvent extension is the ability to send updates and alerts to those who need it and where they need it. So you can see on the right, we have the ability to add or update features in an existing service. We can send email, instant message, text message. We can write out to the web via WebSocket, as well as write out to some of the big data stores like MongoDB and Hadoop, where you might want to do some archiving of that real-time data, in which you might want to later do some additional processing or analysis on that data. So what I'd like to do in this first demonstration is just kind of illustrate how easily you can incorporate a real-time stream of data. So this is typical social media monitoring type of scenario. We have a lot of law enforcement, emergency, and disaster response agencies that are really interested in monitoring social media, especially around some of the larger incidents like riots and Katrina and all those. They really want to monitor what people are seeing in the field, so this gives them a mechanism for doing that. So let's move over to demonstration. So what I'm going to do first is we're going to kind of delve a little bit into the GeoEvent extension here and show you how you actually connect to, create an output, and then create a service that essentially maps the data and where you want it to go. So let's just log into the manager here. So you can see we have a number of one service, a number of inputs, as well as a number of outputs. So I've already created an input that is connecting to the Twitter API data feed. So you can see if I look at the properties of this input, my OAuth credentials for connecting to Twitter. And in this case, we're going to be, you can follow certain user profiles, but in this case, we're going to follow some keywords: Esri, iPhone, iPad, and Android. We should almost guarantee be able to get some tweets with these keywords. Thank you. So now that we have our input created, we can just come over to the Outputs tab here, and I'm going to add a new output. So we're going to choose this output, where we want to actually add a feature to display these tweets on the map. So I'm going to name this tweet feature service up. And we're going to choose my server in which this feature service lives, my tweets feature service, and the layer that I want to send my tweets to. So I'll save this. Now we're going to create a GeoEvent service, and this is essentially a component that allows you to map how and define how you want the data to flow. So I'm going to add a new service here. I'm going to call this Twitter Monitor. We'll click create. So now you can see we have kind of a canvas-like experience here. We can drag and drop components, inputs, outputs, into this. So I'm going to drag both my Twitter input that we looked at, and we're tracking those keywords, and the output that I just created. Now I could connect these and essentially send every tweet that has those keywords to the feature. But many times, tweets do not have geolocation enabled on them. So what I want to do here is add a filter that actually filters out just the tweets with geolocation. So this is a great example of the additional processing and analyses you can do on the incoming stream of data. So I'm going to drag and drop a new filter on here. I'm just going to name this filter geolocated. And we'll define a quick expression here. So when the incoming field, geolocated field, is equal to true, we'll essentially filter out all of those and write those features to the feature service. Okay. So now we can drag and drop these and drag and drop these. So that's our service. That's how the data will flow from Twitter into GeoEvent and out to the web. So now before I click publish, what I want to do is open up another application called the Operations Dashboard for ArcGIS. Has anybody used this application before? It's essentially a free application that Esri provides. It allows you to, it's a great application for visualizing real-time GIS data. So you can see I have several operation views of what they're called here. And in this case, we're going to use this Twitter operation view. So I have a standard grayscale base map here. There's no tweets appearing in the map this time. So if we go back and now publish this service, you can see now that we have already received 41 tweets and so on at about 15 per second that we're receiving. And there we have a tweet that just went out, so we should, if we go back to Operations Dashboard, we should see a tweet here that says iPhone, and it is a keyword. Now, if we zoom into the Southern California area, and hopefully this works today. Sometimes this service is a little sketchy in the basement, but I'm going to open up the Twitter app, and I'm going to actually compose a tweet. And I'll just say, hello, you of space, you are, and I'll just put keyword Esri. Now I'm going to tweet this and see if it appears on the map. There it is. So you can see how quickly GeoEvent captured that tweet. Did the processing and then displayed it on a map. All right. That is the end of that demo. Any questions before we move on? So what I want to do now is just, sorry, go ahead.
Was that a pre-configured like template within the dashboard, operations dashboard?
Yeah. So you can define within the dashboard. You can build multiple operation views. So that was just basically a standard operation view for receiving Twitter. So you can define your base map, your data sources, your update intervals.
So you're not reinventing the wheel necessarily.
No.
It's awesome.
Yeah, that's all. Everything you saw in the operations dashboard was configurable. All it was doing was referencing the feature service, that tweets feature service that was set by ArcGIS server.
Oh, okay.
Or you could reference ArcGIS on your items as well. Yes?
How long does it stay up there? Like if you're doing a real-time mapping like that, is there a setting for that, or?
Well, the service, hypothetically, the stream of data, you could just leave, we have law enforcement agencies and FEMA and all these other agencies that are just continually processing and monitoring this Twitter data and other social media data. It just depends upon, I guess, your use case. If you have a public-facing application that you want the public, maybe the city of Redlands, right, has a public-facing application that they want to make available to the citizens, right? So then in that case, you'd have an application running. Does that answer your question?
You can actually specify within the output connector as a GeoEvent extension. You can specify delete all features or for how long you want to keep the features on the map. Yeah. And GeoEvent will, on this refresh interval, delete all features.
Yeah. So how we receive data into the GeoEvent extension is obviously using input connectors. So we just wanted to highlight this, that these are some of the input connectors are available out of the box that you can connect to. So you can receive RSS feeds. So if you want to go to an RSS feed from the National Weather Service and incorporate that and display weather alerts in your map, you can do that. And a bunch of other, you can receive text from a TCP or UDP sockets, receive features on the REST endpoint, a lot of other different ways in which you can connect to and receive that data. We also make a number of connectors available as community-based connectors. So the Esri Gallery connectors here are connectors, we just use the Twitter connector that we make available online with associated GitHub projects that you can go and modify, access the source code of those, and modify the actual properties of those if you need to. And we've worked with a number of Esri partners, obviously, to develop other connectors for their specific services. So those are listed there. The key here is that if these connectors do not meet your needs, you can use the GeoEvent SDK to develop your own connector. Maybe you have a unique data format or a unique system that you need to connect to incorporate that real-time feed. You can use the SDK to develop your own. Now on the output side, we just created an add a feature. So we're adding a feature to that tweets and to the tweets layer, and that's why it appeared in that. You can also update a feature. You can send an email, instant message, text message, and others here as well. Gallery items for output connectors include the ability to actually send tweets, some of the enterprise messaging systems like ActiveIQ and OpenQ, and then support for sending out to some of the big data stores like Hadoop and MongoDB that I mentioned. And again, on the output side, create your own connectors using SDK. All right, next demonstration. So this is a great demonstration that really highlights some of the real-time analytics that you can perform in real-time GIS. So we are going to be essentially monitoring vehicles here and present these vehicles or ourselves with several scenarios. So let's go back into Operations Dashboard. You can see we've received a number of other tweets with those keywords all around the world. Yep. So if I close this, and what I'm going to do is open up another operation view here. And so this is the ambulance monitor operation view. So let's assume we're an emergency responder agency that is interested in tracking all the fleets of vehicles that they have deployed around the field. I'm going to open up this operation view. You can see this a little more comprehensive operation view. We have our standard base map with some hospital locations, but we also have an alerts widget. So if we receive any sort of alert upon an incident happening, we will see an alert here. So this is typically a display that an operations room or some other back end that's actually managing their fleet of vehicles would see. This is not something that an ambulance driver would necessarily interact with. Ambulances widget, so when we have ambulances being received into GeoEvent, those should appear here. And then a geofence widget that essentially allows us to create static geofences on the fly, or spatial polygons that we can detect certain patterns of interest. So, since Esri does not have a fleet of ambulances out in the field, I'm going to use a little utility that is delivered with the GeoEvent processor that actually allows you to simulate real-time GIS data into GeoEvent. So, you can see I'm connected on this port 5566, and I've loaded in an ambulance CSV file there. And I'm going to define the playback variables right here. So, if I go ahead and click play, we should start to see ambulances appearing on our map and then moving around. So maybe we want to explore this ambulance 15 a little closer. So we can double click on him to zoom into him. We can also see the speed of this ambulance at the current time. So within the dashboard, you can choose to highlight that ambulance. If you want to follow that particular ambulance, you can do so. So there's a lot of other little capabilities you can do as an operations person for tracking and monitoring the assets. Now in a moment here, if you look at the speed, he's going to exceed 70 miles per hour. There's an alert created for that. He's going too fast. So ambulance 15 is speeding, and what we're doing is capturing the duration of that particular incident. So after he stops speeding, you can see that the incident is now ended, and it lasted for 8 minutes. Now in this next little scenario, let's assume there's a high wind advisory. On this bridge, and we want to notify the driver of that. So I'm just going to create a static geofence here. That is a hypothetical wind advisory. This could very easily be a real-time, and we already got the alert that ambulance 15 is inside the dangerous area, and it's ongoing for the last X minutes. So this could very easily be a real-time stream of weather that you're connected to a weather service provider. So this could be a real weather system moving in, and you can alert the ambulance upon that event. Now in this next little scenario, what I want to do is, let's presume we have a critical patient on board, and we want to notify the hospital staff that when we're 5 minutes away from the hospital. So I'm going to add another geofence here. For hospital A. And in this case, we're going to actually calculate a drive time, 5-minute drive time from this facility. And let's save that. So now as this ambulance approaches and then enters the 5-minute drive time boundary, we should see a couple things happen and hear a couple things hopefully happen. Well, we should see an alert pop up just like all the other incidents, right? And we'll let this do that. Alert popped up. And hopefully, service is okay. Regardless, I should have received a text as well as an email to my phone stating essentially that ambulance 15 is approaching, arrival in 5 minutes. So we'll probably hear that come through in a minute. Okay, so now how did all this work on the back end? So what we'd like to do is just kind of step you back into the manager and just show you a really simple service that allowed us to demonstrate this capability in these 3 scenarios. So let's go back into the manager. I'll come over to the monitor tab, and you can see we have another service. Let's look at this quickly. So this is the service. It's a little more comprehensive than the Twitter service, but essentially what we're doing is reading data from that port 5566. And we were writing that data to a vehicle feature service, and that's how we saw all the vehicles just be displayed on the map. Now at the same time, we had several analytics processors running here. This one supported the first demonstration, where we were alerted upon the speed exceeding 70 miles per hour. So you can see here we have just a simple speed greater than or equal to 70 miles per hour. When that happens, or when the ambulance exceeds that 70 miles per hour, we're going to create an alert, and we saw the alert appear on that. Dangerous area monitor, so this was the high wind advisory. So essentially we're detecting when an ambulance intersected a polygon or geometry of any dangerous area. And when that was the case, we again wrote a feature to the alert and displayed that information. Now this last one supported that 5-minute drive time. So in this case, again, we had another processor here that was in real time detecting when the geometry of an ambulance, or when the ambulance location entered a hospital proximity. And when that was the case, we saw an alert as it's connected. But at the same time, we should have received a text to my phone, as well as an email to my account as well. So that one service here, GeoEvent service, all three of those different monitoring type of scenarios. I'll now hand it over to Sam.
Thank you, Greg. Thanks for these nice presentations. And I just want to talk briefly about how we actually visualize real-time data in our application. So as you have seen in the demonstration Greg just showed, we usually have the GeoEvent extension running on our GIS server. And it's updating or adding features to another feature layer, and which is also hosted on the server. And the client application, which was in this case the operation dashboard, just pulls these features according to a certain refresh interval to update it in the client itself. And this is what we would like to call near real-time, because it's still dependent on this refresh interval. What we are going to do in our next release is that we add the capability of so-called stream services. And now you can actually send features to a stream service which uses a WebSocket. And the WebSocket is basically a bidirectional connection between the server and the client application, which pushes the features directly from the server to the client, where they are visualized as soon as they are received. This is like more real-time than compared to this refresh interval we used in the earlier demos. And I just would like to show you this new technology with another demonstration. And for this demonstration, I would need all of your help, because I want you as an audience to create a real-time data stream. And therefore, I created a simple form, which you can access by this given URL on any of your devices. I hope some of you brought a smartphone, tablet, notebook, so you can access this URL from any device. And I would just ask you to enter your name and choose one state of the US, maybe the one that you are born in, or simply which is your favorite state. And if you would like to experience a notification system of GeoEvent, you can also provide your telephone number and your carrier, and you should at least receive a text message if it works down here, as soon as you participate in this demonstration. And you don't have to worry about the data. We're not going to store any of this data, it's just for the demo purpose, of course. So I'm just going to switch over to the actual map so we don't miss anyone here. It's already joining this one. Oh, we already have one participant. And Greg has also joined this demo. And as soon as you send the data to GeoEvent, you're able to just play with your symbol on the map, just move it around, or change the color and the symbol size. And what I want to demonstrate with this demo is actually that as soon as you press a button, the feature changes on the map. So because we are using this new streaming technology to push the features to the client, and it's visualized as soon as it received. Can I get any feedback if the text message service worked?
Yep. Yeah,
It's right at the
Top right corner. links.esri.com/UFR. And we see many people from California. So what actually happens here in the back end is that you send the data to GeoEvent using this form via a WebSocket connection. In GeoEvent filters if you want to receive a text message or not, and does so if you want to, and displays or send these features directly to the client using this new stream service technology. And limit this one to the yes. Zoom out, should be good. Oh, there. I'm just trying to move over. So I hope this symbolizes how fast real-time data processing actually works. Do you have any questions to this short demonstration?
I never broke this one, so I have
look like it's better on this one.
yeah. I've been at it almost 5 years already. Oh, it's okay. Thank you.
Okay. Is everyone able who want to participate?
You can't get it to work.
It's all right. I'm a Chrome server.
Or we can try it after the presentation Q&A session. Okay, because then I would move on and actually show you how this new streaming technology can also handle a large amount of data, because we're now able to really stream a large amount of data in real time into our web app. And at the same time, I'm going to show you how easy it is to create your own web application using ArcGIS Online. Is everyone familiar with ArcGIS Online? Have you tried it before? For the ones who are not, it's basically, ArcGIS Online is a web GIS, which I talked earlier about, provided by Esri. So you can use services and integrate them in your map. And for this demonstration, I would like to add a service from the Federal Aviation Agency, which shows all the flights in the US, or the position of all the flights in the US in real time. And therefore I'm going to go ahead and search for this layer. Search for FAA. And now you see I found the FAA stream layer, so it's this new streaming technology as a service in ArcGIS Online, and I'm just going to go and add it to the map. And you see that all the location of the flights in the US are streamed into my web map. Since this blue dots doesn't really mean anything, since the blue dots doesn't really mean anything yet, I'm going to change the symbol size a bit to make it more look like planes. Here we go. I'm going to use the plane symbol. Apply this one. So now it looks more like planes, but it still looks kind of funky because they're all pointing north. So I actually can go ahead and since this stream service provides us with a heading of the plane, I can use this heading information to set the rotation angle. So I'm just going to use this heading information over here and apply it. And now at least the planes are pointing towards the direction which they're actually flying to. But covering the whole US is kind of a bit messy because there are just too many planes out there. So let's just focus on a bit smaller area, let's say here in the LA area. And if I want to track flights, I can actually not only symbolize the latest observation, but also past observations, and connect these observations using a line. So I can go ahead and say, okay, I want to have the 3 last observations displayed as well, and connect the symbols using a line. And now you're going to see as soon as a plate moves, for example this one, you see the last observation and then the next one displayed on the map for a while. So I'm done changing the symbols. And if I'm only interested in this specific area, I can limit my observation as well to only this area using the streaming control and limit it to the current map area. And now only incoming features in this area are going to be displayed on the map. So if I zoom out again, it's still only the planes in my area of interest which are displayed. But let's assume that we are working for the LAX airport in Los Angeles, and we only are interested in flights that are going into LAX, so to monitor these flights. So now I applied a spatial filter for a certain region, and I'm going to change this filter now to an attribute filter. So I'm going to go ahead and show all observations again, and then apply a filter here, using the destination ID, which is LAX for the LAX airport. Apply this one. And now only the planes which have the destination LAX are going to be visualized on the map. As you see, the heading there, and if you zoom out, all the planes are displayed that are heading towards LAX. So this is how easy you can create actual web map. And if you want to share this web map with other users, and the user should be able to kind of interact with this application, it's better to create a web application out of this web map. So I'm just going to go ahead and save this map. FLA monitor LAX using the FLA tag, and save the map. Now I can share this map after I saved it, make it public, and then I have the option to either embed this web map in the website, or I can create a web application. And if I want to create a web application, Esri provides us with a bunch of templates that you can configure to your need, or you can even use a new web app builder to create your own web application template. For this demonstration, I'm just going to go and preview one of the given templates. And this is actually how the web application would look like. It works. Give it a minute, and then you see you have now a nice web application where the user can actually interact with. So instead of displaying the legend, you can use an overview map, for example. You could change the base map if you rather want to have the light gray base map that we've seen before in the ambulance demo, in the Twitter demo. So the user can really customize this web application to their own needs. Any questions to this demonstration? And I just want to give you another couple of examples how we can use this new streaming technology of Geodon. And I have two other examples. This one is a thunderstorm moving towards the east coast, and we can actually create a buffer zone around this moving polygon to alert the station at the ground before the actual storm hits it. So as soon as this polygon moves over one of the ground stations, an alert is created and we can send out a notification. For example, in this example, an email which contains a URL to a new web map, and the user can display this web map on any device to see where the storm is actually located before it hits a location. Another example would be the separation of a convoy. So if the convoy for some reason is separated, we want to be notified, as just happened in this example over here. And how does it actually work? So we can, using the streaming technology, create these buffer zones around the vehicles and synchronize them in real time so that they move with the vehicle along. And as soon as one of these buffer zones disjoins from the other buffer zones, an incident is created which is valid as long as this vehicle is separated. And as soon as the vehicle joins back to the convoy, this incident stops and you can display it on the map for further use. Any questions about this demonstration? And I'll hand it over back to Red. Okay. Oh, one question?
What a new kind of a feature service for streaming data?
Yeah, it's called the Streams now. So it's, you actually go back to.
Has it been released?
It's going to be released in the next release, which is coming up. Yeah, in a few days. Yeah.
Middle of December. So I guess what we'd like to do now is kind of highlight some actual success stories of organizations that have actually implemented real-time GIS and are using this technology to manage their day-to-day operations. So the first one here, obviously after the unfortunate incident at the Boston Marathon in 2013, the race coordinators really needed to beef up security along the entire race course. So what they did this year is utilize the Geodon extension to track and monitor all of their assets in the field. So every runner was equipped with an RFID tag in their bib. And when they crossed defined waypoints, like the start, the 5K, 10K, and eventually the finish line, GeoEvent obviously picked up all of those signals from the thousands of different runners at the event. And what this allowed the race coordinators to do was actually move their security staff along the most densely populated areas. So this is the actual example of the operations dashboard that they deployed in their operations. And you can see by the, obviously might not be able to see this from the back, but to start, the 5K had 11,800 runners at this moment that the screenshot was captured, right? And all the way down right here. So at this time, the 30 to 35K only had 123. So they were able to move their security staff accordingly where the most densely populated group of runners was. Another really interesting one is the 2014 Ironman World Championship, which was held in Hawaii this year. So the Race Operations Center used GeoEvent to track all their assets in the field. So that included like the bike technicians, all the medical units that were responding to any injuries or other incidents, as well as the race sweeps. So we're picking up all the leftover race gear and stuff. So in this case too, the athletes were equipped with the RFID band on their ankle, and the race coordinators were tracking as the actual athletes crossed over sensor reading mats that were positioned throughout the race. The race coordinators really knew where every single athlete was in the race. So this is an example of their internal portal that they made available to all their race operations. So they had multiple applications depending upon who was actually doing what sort of monitoring. So they had desktop applications, they had mobile applications, another mobile application, and then a public information application that allowed the general public to view information about the position of athletes during the race. So this was actually the operations dashboard that they deployed, and this is the one that was managing all of the incidents relating to the athletes. So at the time that the screenshot was captured, there were 5 incidents. You can see the details of each incident, whether it was a medical or bike incident, as well as the severity. So there's 1 severe incident and 4 not severe or normal severity incidents. So another actual picture of the Race Operations Center. You can see the dashboard up on the display up on the wall. So this was actually the Race Operations Center for this event. So at future events, so what they want to do is provide some additional capabilities. They want to actually do live tracking of the athletes, not just when they cross waypoints, but have a GPS or some other GPS device on the athletes so they can track them at every single position that they are throughout the race. They also want to do some more analysis on the medical tent status so they can provide more real-time information on when bid 1743 has entered the medical tent, what the status is, and then when he leaves the medical tent. And then again, another great example of incorporating social media feeds. They want to incorporate, again, social media feeds for law enforcement purposes so they can respond accordingly where there seems to be more activity at the event. So another success story here that's a little closer to home is the City of Los Angeles Bureau of Sanitation. So they have equipped all of their 700 trucks that are serving 1.3 million customers and 2.3 million trash cans and containers a week with sensors. So the sensors on the truck are measuring the number of arm lifts that the arm lifts in a particular day. The container weight, so if the container is too overloaded to lift and it's going to break the arm on the thing, they won't take it. Driver performance, so there's telematics devices in these that are measuring how good the driver is driving, right? As well as equipment malfunctions. So if the arm lift breaks, then they know back at central headquarters that the arm on this particular truck is broken. And then it also tracks required maintenance. So every 3,000 miles, get your oil changed. So in addition to the truck having sensors, all the containers have sensors. So they're equipped with RFID tags. So every time a truck picks one up, it reads the RFID tag, and the city can now verify that this resident's container is picked up. And this has alleviated a lot of complaints, or supposed complaints, that trash cans were not picked up this week. Because people, trash truck comes, picks it up, they take it back up, fill it up with more, and call the city and say, hey, you missed my trash cans. Right? So now they can have proof that, no, we didn't miss your trash cans. So it's
Eventually charge more for him because he puts out more trash and me because I recycle.
Yeah, depending on the weight of your trash. That is actually the scenario that they discuss. The heavy users of the trash. The trash
Don't
industry.
you put it in my garbage can.
So they've essentially really improved their customer service. They are reduced their operational costs, obviously, and gained a lot of other efficiencies. And actually, last month, the mayor of LA presented them with an award for their innovative use of technology. And this is the technology that they invented. Last one we'll cover here is Dong Energy. And remember, this is not only about moving assets, tracking trucks and people. It's about tracking and monitoring sensors that might be out in the environment that are stationary. So Dong Energy has installed sensors on all of their 1,000, 1,500, whatever it is, wind turbines in all of their wind farms over in Europe. And so what they're able to do is monitor the operational status of these turbines. So if something malfunctions and the turbine stops working, then they're immediately alerted upon that incident, right? And they can send a crew out to fix that immediately. It's also allowed the operations staff to respond much more quickly, obviously, to incidents of that nature. This has obviously led to a reduction in the maintenance costs. They have been visiting every single one of their towers 4 times a year just to check in and make sure everything is working. Now they can just do that 2 times a year, maybe eventually 1 or none times a year. Right? But they've cut they've actually realized like a savings of $25 million a year just on incorporating these sensors and monitoring this real-time information.
And back over time. Thank you. So now that we have seen where GeoEvent is already implemented, I just want to talk about a bit about the future of Real-Time GIS and where are we going. Definitely one emerging trend is the Internet of Things. I don't know if everyone of you have heard about the Internet of Things, but it's basically to compromise every device that is connected to the Internet. And already today we have more things connected to the Internet than people living on the Earth. And in fact, at the end of this year, so basically almost now, around 16 billion devices are connected to the Internet, which is 20% more than last year. So it's really an exponential growth that we experience. And the predictions are that in 6 years, so by 2020, around 40 billion devices will be connected to the Internet. And if I talk about devices or things, it's not only this big objects like you see here, like planes, satellites, any kind of vehicle, vessel, or sensor networks. It's also really small sensors like wearables, or even there's a startup who has implemented sensors on cattle to monitor the health status. So it's like really every device which is connected somehow. And I just want to give you a few examples, a few ideas about it. So we can talk about connected vehicles, and we already have kind of collision sensors who warns you with a haptic feedback if you're in danger of a collision. But we can think this further, so that the vehicles can really sense each other and interact with each other, but also incorporate other kinds of data, for example from weather stations as they pass through this area, and adjust the behavior accordingly if the road is wet or icy. Another example would be connected buildings, and we're talking in this context often about smart cities or about smart workplaces, as in this example, where not only the buildings are connected, but also the workers and vehicles in the same space, because they share this location to enhance work safety. And especially in a production site like on this picture, it's pretty useful because we have a lot of restricted areas or working with hazardous material. But we can also connect to our environment. And I like this example because it's actually a vineyard which is using GeoEvent, and they have implemented already sensors in the ground to measure the soil moisture in order to better water their grapes, because grapes are pretty sensitive fruits, so they enhance their watering practice. And they plan to integrate more sensors using other environmental parameters, or also monitoring their vehicles to optimize their harvest. Another example is that we can obviously connect people, and there's one startup who's creating sensors as necklaces for kids. So if they go on a field trip, they all be equipped with a necklace containing a sensor. And as soon as one of the kids is moving away, too far away from the group, the teacher would be notified on their smartphone and get an alert that one of the kids is in danger to get lost. So this would be a modern solution kind of for the frantic and frequent headphones. And where this necklaces are a pretty straightforward example, there's a more futuristic view, which is a video provided by the Bureau of Land Management, and they actually work with firefighters and equip them, or create this video as a kind of vision what is possible with wearable sensors, so in the suit of a firefighter. And I just would like to share this video with you. It's unfortunately in quite low resolution, but I hope you can recognize anything still. So this guy has an augmented reality display kind of where he can view his own health status and the connection status to the team radio, for example. And now he gets a call from another firefighter, and he can go to the team status and actually use the point of view from his colleague to see where the fire is located, because he obviously discovered the fire, including a map to see safety zones and the health status of his teammate. But you can also check other sensors in his kind of wearables, in his suit, to see if any contaminants are found. And in this case, he was lucky no contaminants were around. This is kind of a very futuristic video, where are we going, but all the sensors kind of can be connected and even implemented in any device, like even your clothes. So to summarize this review kind of the Internet of Things, I think it's obvious that geospatial reasoning, so using this geographic information, geographic analytics, is a key component amongst this Internet of Things. And if to tie it back to our product, to the GeoEvent, we're probably going to go more into the direction that's going to get away from sending all the data to a centralized server, but rather implementing lightweight versions into the things itself. So any gateway kind of is, can be the thing itself. So you can have lightweight versions in a car, in a building, even in wearables, everywhere where a ship fits, can have a real-time GIS kind of implemented. So the geospatial reasoning becomes closer to the actual thing. And of course then you can monitor all the data derived from the sensors in real time, and as soon as a meaningful pattern occurs, you can notify people or even notify other things, so the things can actually communicate to each other. Okay. Any questions so far? Okay.
Okay, so I think that kind of wraps up our presentation, and hopefully you guys have gained some insight to real-time GIS and some of the capabilities, use cases, and some of the really neat success stories that we've already realized with real-time GIS. So, provided some more information here if you want to learn more about some of the real-time GIS resources that Esri provides. Follow these links. We have a wealth of tutorials that are available at that link, obviously. So if you, in fact, have access to the Geodon extension here on campus, you can start working with those, consuming real-time data, simulated. So we also have a real-time GIS community that we encourage everyone that is interested in real-time GIS to join at the link there, as well as the Geodon extension forum. So if you actually do start using the extension, you can post questions, and the development team and others respond quite quickly to those typically. So, questions?